If we are finding the difference of these two polynomials, if you remember when we found the sum, what did we do with these two? Yeah, we combined them, we added or subtracted based on what was in front of them. When they were in the parentheses, did we have to do anything extra to them? No, we just rewrote them, right? Okay, is there any number in front of 2x squared plus 4? Or any sign in front of there? No, I'm going to bring it down then. This is in your pencil. I will tell you when we're using a pen. Alright, how about minus 4x squared? How is that different than what we did last week? It's subtracting. Here's what you need to know about subtracting, and here's why you have your red pen. Subtracting is like having a negative 1 there. It's in red, even though it's hard to see it's red. And I'm going to distribute that negative 1 to everything inside the parentheses. Now, it just so happens there's only one thing inside this time. There won't always be. So what is negative 1 times 4x squared? It's what? Throw it away. Yeah. If for any reason your pen doesn't work, throw it away and grab a new one over here. Once you have changed the second set of parentheses, meaning you've distributed the negative 1, it is not any different than what we did last week. So what do I do now? Combine like terms. What like terms do I have? 2x squared and negative 4x squared. What is 2x squared minus 4x squared? Negative 2, and remember I don't change x squared. Does 4 have a like term? So what do I do with it? Is that in standard form? Yes, then I'm finished. The only difference is I need to distribute that negative. I'm going to look at number 2. Remember, if it helps you to highlight the like terms, maybe pull out your highlighter. Number 2. Is there anything in front of the first set of parentheses? So what am I going to do with it? Bring it down. Is there anything in front of the second set? A negative 1. So write a 1. And then do what? Distribute. What is negative times negative give you? Positive x squared. What is negative 1 times negative 1? Take 2 this time, and if one of them works, good. Are there any like terms? 4x squared and x squared. What is 4x squared plus x squared? Okay, 5x squared. Okay, the other one does. I should have just given you the bucket this morning. You could try them all. Alright, does negative x have any like terms? No. What do I do with it? Okay. Does 1 have any like terms? What am I going to do? Okay. Is it in standard form? Then I'm finished. I want you guys to try 3 and 4. I'm going to zoom out because some people were having pen problems and might need to look at number 1 again. I'll show you 3 and 4 again in a minute, but there you go. All right, number 3. Remember, those are z's, not something else. I have negative z to the third minus 2z minus 1. Is there anything in front of that set of parentheses? No. Starting tomorrow, there will be. Which is why I keep asking you, is there something in front? I need you to make sure you always pay attention to, is there something in front or not? All right, is there something in front of this set of parentheses? What is it? Negative 1. Some of you are getting to the point where you realize I can just change all the signs instead of having to write distribute, but you get to decide. So this becomes what? Z to the third. Yeah, plus z to the third. All right, negative 1 times 2z. Okay, and negative 1 times 1. Are there any like terms? Okay, negative z to the third and z to the third. Combining those gives us what? Nothing. It's 0. So, remember, this was on your homework from when were we here last Wednesday? You had one where every single thing crossed out. I think that was the first one. And if you're like, oh, I didn't have that, maybe you should check it later. But you did. So, your answer would have been 0 if everything crosses out. Now, is everything going to cross out on this one? No. If you had forgotten the sign change, it would have. Okay, what else is in common? Negative 2z, negative 2z. What is negative 2z plus negative 2z? Negative 4z. Okay. Anything else? Okay, negative 1 and negative 1, and you told me that becomes what? Negative 2. Is that in standard form? I'm done. Not a too bad a thing to come back to. It is kind of a nice review if you forgot what we did last week. Number 4. Like I said, number 4, that looks like an I on complete accident, and every single year I forget to change it. That's a 1. Do we need to change anything in the first set of parentheses? So 8y minus 7. This is also why the other day we brought everything down, even though it might not have made sense, so that we would remember that sometimes we have to distribute things. Alright, what is negative 1 times 1? What is negative 1 times 3y? Okay, positive 3y. Are there any like terms? 8y, 3y is 11y. Okay, negative 7, negative 1, you said that is negative 8. Okay, how do you guys feel about this stuff so far? Thumbs up if you're good. You still kind of need some work is in the middle. No ideas at the bottom. How you feel about this? Okay, thank you. 11y minus 8. Fold this in half. We're still going to keep working on this. And glue it in. That's all we're doing today. Glue it in on page 94. And then keep your notebook out, because we're going to do some more in your notebook. Alright, so before we start numbers 5 and 6, you need to check out page 833. Alright, number 5. What did you guys do first? Brought down the first piece, 2q squared minus q minus 8. Okay, then what? Okay, put a negative 1. Negative 2q squared minus q plus 4. Okay, these 2q squared. One is positive, one is negative, so you said they cross out. Okay, then what? Negative q and negative q. What does that become? Negative 2, because it's like a negative 1 and a negative 1. Negative 2q. Okay, now what? Minus 4. Where did you get minus 4 at the end? Negative 8 plus 4 gives us minus 4. Very good. Okay. How did you start number 6 then? Yeah, just like the other one. Bring down the first one. Okay, then what? Distribute that negative there. This becomes what? Positive. Okay. And then what's negative 1 times y? Negative y. And negative 1 times x. Quite a few things on this one cancel out. Alright, what like terms do we have? And what is negative x to the third plus x to the third? Okay. Do we have anything else that's like terms? You have what? Okay, the y's. What's y minus y? Those cross out as well. That's pretty simple. Alright, do we have any other like terms? Negative x and negative x. What does that become? Negative 2x. What do we still have that we need to bring down? Is this in standard form? No. Y squared minus 2x is standard form. It's only alphabetical order if they have the same exponent, and they don't. Okay, we're going to talk about page 833 next. I'm going to leave this here for a minute, but I'm going to erase that. Just like we did the other day, we're going to do the word problems from our book. You need to cut out 9 and 10. Leave them together. There's no point in cutting them separately. So blue in 9 and 10 from 833 right underneath that word problem, we just did. Alright, so number 9, Jen, a biologist, here's Jen, is growing bacterial cultures at different temperatures as part of her research. The number of cells in the culture growing at 25 degrees Celsius is given by the polynomial t squared plus 4t plus 4, where t is time. That's important. I want you guys to take your green highlighter and highlight this polynomial. Remember, that's in green. And that's the one that's growing at what temperature? Okay, we're going to highlight the 25 degrees. Not because we need 25 degrees in the problem, but that's going to help us determine which one we're subtracting from which. It's in green. The number of cells in the second culture growing at 35 degrees Celsius, in orange, is modeled by the polynomial t squared plus 4. She needs to measure the success of the 25 degree culture over the 35 degree culture. Our question, in yellow, says, find the polynomial representing how many more cells are in the 25 degree culture for time t. We want to know how many more are in this one compared to this one. How are we going to subtract? Which one goes first and which one gets subtracted? we start with the 25-degree culture because it says the 25-degree culture should have more. So that means we're going to start with that one. Okay. This should have more than the 35-degree culture, so we're going to subtract the 35-degree culture, which is t squared plus 4. Now it's not any different than what we just did. What are we going to do with the first polynomial? Bring it down. What are we going to do with the second polynomial? Distribute a 1, a negative 1. Minus t squared minus 4. Okay, then what? Okay, I've got t squared minus t squared. What is t squared minus t squared? 0. 1 minus 1 is 0. Okay. Do I have any other like terms? What is positive 4 plus negative 4? 0. What's the only thing left? We have answered the first question, which says find the polynomial. But is that all this problem asks? No, we got to keep going with our yellow highlighter. How many more cells are there after 15 minutes? What did T stand for? Time. How do we find how many there are after 15 minutes? 4 times 15. 60 cells. I needed to have both answers to get this completely correct because it asked for both. Okay, number 10. The number of gallons of water in a leaking pool is determined by the rate that the water is filling. So we're going to highlight that in green. We've got a pool that's filling at this rate, 8g squared plus 3g minus 4. That's in green. And the rate that the water leaks. Now, just as an FYI, if your pool leaks, please quit filling it. 9g squared minus 2g minus 5. Where G represents the number of gallons entering or leaving the pool per minute. Write an expression for the net change in gallons per minute of the water in the pool. Which one do you think we're going to subtract? We're probably going to subtract the leak because it goes in and then it's going to leak out. So you guys are right, subtract the leak. So that means we need to start with 8g squared plus 3g minus 4. And you guys said subtract 9g squared minus 2g minus 5. I bet you as big as that polynomial is, if you're putting it in too slow, it runs out faster than it goes in. Okay, I'm going to bring down 8g squared plus 3g minus 4 and distribute a negative 1. So negative 9g squared plus 2g plus 5. Do I have like terms? What are they? 8g and negative 9g. What is that? Negative what? Negative 1g or just negative g squared. Do I have any other like terms? 3g and 2g. What's that? And negative 4 plus 5. Plus 1. Am I finished with that problem? No. What does it continue to say? So what am I going to do to find, if it's going in at 5 gallons per minute, how do I find out how many's in there? What? Plug in 5 for G. So this is part of the answer. But I got to keep going. So I've got negative parentheses 5 squared plus 5 times 5 plus 1. Find out what that is. So if it's going in at 5 gallons per minute, which seems like a lot, I don't really know, rate-wise, we got to find out what we got left. One gallon. So if you're pumping in water at a rate of 5 gallons per minute, only 1 gallon is staying in that pool at a time. Fix the hole. You are wasting water.